Okay, this is section 4.2. Here we are going to look at about two events. Those who are mutually exclusive. Two events are mutually exclusive events, or you could call those as disjoint events. If both of them cannot occur at the same time, right? In another word, we cannot find common outcomes for both events. Those type of events are called mutually exclusive. So look at these examples. Determine whether the two events are mutually exclusive. Explain your answer. You are given two events for each problem. So you need to identify whether those two are mutually exclusive or not. Randomly selected a female student. So this could be thought as like a first event. And selecting a student who is major. This is like my second event. So basically you are given two events, right? So now ask yourself, can this happen at the same time? Remember, you are selecting only one person. That person should be a female at the same time, should be a junior. Yes, it is possible. So you could select a female junior, right? Therefore, these two events can happen at the same time. Therefore, this is not mutually exclusive. Look at the second one. We are selecting a person with type A blood and selecting a person with type O blood. So remember, you are selecting only one guy. So is that possible for us to have, with these two happening in the same time for each person? So it's not possible, right? Because you are selecting a person. So it should be either one type, not both. Therefore, yes, this cannot be happen. So this is yes, mutually exclusive. Okay. Next one. Rolling a die and getting an odd number. When you roll a die, you could get an odd number. Rolling a die and getting a number less than 3. Ask yourself, is there any possibility to have a number which is odd and at the same time less than 3? Of course, one is there. One is an odd number which is less than 3. So it is possible to have these two even at the same time. Therefore, this is not mutually exclusive. Last one. Randomly selecting a person who is under 21 years of age, randomly selecting a person who is over 30. Is that possible to have these two at the same time? No, you should be either, it should be a one age, right? We can't, have two different. So it is not possible to have these two at the same time. Therefore, yes, this is mutually exclusive. Okay, so the next one, there's a rule for adding two events with a probability. So if two events A and B are mutually exclusive, so this is a given condition now. You are given two events, those who are mutually exclusive events. If this is the case, then probability of event A or B is given by simply the sum of those two. Okay, so this is a very, very important result we have when you find two events with or. Now let's look at this example. In the United States, there are 59 different species of mammals that are endangered, 75 different species of birds that are endangered, and 68 species of fish that are endangered. If one animal is selected at random, so you are going there and choosing just one among all three different types of species, right? Find the probability that it is either a mammal or fish. So we are asked to find the probability of, we are choosing a one species. They are asking whether that is a mammal, or so you could think of two events A and B like this. So I'm using my previous formula. Here we have the probability of A or B will be PA plus PB. Before going to use that formula, ask yourself whether A and B are mutually exclusive. Then only you could use this formula, right? You are choosing only one species. Is that possible to have both at the same time? You're selecting one, should be mammal, at the same time fish. No, these two are two different things. So you can have at the same time. Therefore, this is a mutually exclusive. So two events are mutually exclusive. Therefore, I could use that formula. The probability of A or B is equals to P of A plus P of B. Remember, event A is here selecting a mammal, and event B is selecting a fish, right? So this is my event A selecting a mammal, and this is my event B selecting a fish. Okay, so now the thing is, you need to find these two probabilities separately, right? So remember, in my sample space, I have three different species. Therefore, the total number of outcomes in my sample space, that is n of s, is simply, if we add all the possible outcomes, the numbers, simply just 59 plus 75 and plus 68. Simply add all the possible number of outcomes. Okay, so when you add all these three, you should get 202. That is my number of outcomes in sample space. Remember last time we had a formula for probability of any event E, which is simply given by n of E over n of S, number of outcomes in your given event E over the number of outcomes in your sample space. My event is now A, selecting a mammal. So that means ask yourself how many mammal species are there. So there are 59. So which is 59. That is my n of A. So let me write down one more step here. P of A is n of A over n of S plus P of B is n of B over n of S. So n of A is 59 over n of S is, we already have n s is 202. Then plus P of B is n of B, the number of outcomes in my event B. My event B is, selecting a fish. So there are how many fish we have? There are 68. Therefore, 68 possibilities are there to choose one fish over 202. So when you add these two fractions, that's going to be our answer, which is 127 over 202. So if you round up these to the three decimal places, that is 0.629. Okay. So this is a very good question, very good application for mutually exclusive events with or. Okay. So now let's look at the Venn diagram. How can I express, these two in Venn diagram? Venn diagram for addition rule number one. Addition rule number one is nothing but P of A of B is P of A plus P of B. Remember, this formula is valid only when A and B are mutually exclusive. Okay, mutually exclusive. So you see now, this is the Venn diagram for this. You have two events. This is my event A and this is my event B. So you see now these two events are, there's no, outcomes in common. In other words, there's no overlap region between these two sets because of, disjoint. So if two sets are disjoint, cannot intersect, right? Therefore, this is the clear picture we have for the event A. The probability of that event is PA and the PB is here. So P of S is always 1. Remember, P of S is nothing but the probability of all possible outcome of my sample space. So that is going to be always 1. So P of S is always 1. Okay? So this is simply one expression, one of the several expressions of two mutually exclusive events with addition rule. Okay, now let's move to the next note. Note number 2. The probability rules can be extended to 3 or more events. Remember, I had in previous thing I had only for 2 events. If you want, you could extend that to 3 or more. Simply, follow the same procedure. Suppose if you have 3 events, mutually exclusive events A, B, and C, then the probability of A or B or C is given by simply the sum of all 3. Even you could extend to 4, 5, 6, and so on. So when events are not mutually exclusive, then this formula is not valid. Now you have one more formula for that. Okay? So this formula is valid only for mutually exclusive. Now look at the rule number 2, addition rule number 2. If A and B are not mutually exclusive, then we have a different formula for A or B. The probability of A or B is given by P of A plus P of B minus subtract the probability of A and B. Now this is the part coming from the overlap intersection region of these two events. Okay, so if you look at the picture here, so you see now, unlike earlier, here two sets are intersecting with each other because now we are considering two sets being, not mutual. So not mutual in the sense it is not disjoint. It may join together, right? Therefore, you will have always overlap region for not mutually exclusive. So if it is not mutually exclusive, simply use this formula to find the probability of A or B. Okay, so when you do the problem, first of all, you need to figure out whether two events are mutually exclusive or not. If it is mutually exclusive, then use the first rule formula. If it is not mutually exclusive, then use this formula, rule number 2 formula. Okay, so now look at this example. Example 3. A single card is drawn at random from an ordinary deck of cards. Find the probability that it is either 9 or diamond. So that means the question is finding the probability of getting number 9 or getting diamond. Okay, so you could think of this as like my event A, you could think of this as event B. So the question is finding the probability of A or B, right? Before going to do this, ask yourself, are these mutually exclusive? Remember, you are choosing only one card. That card should be number 9 with diamond. Yes, it is possible. There are 4 suits, right? Diamond is one of those, so definitely you will have number 9. Yes, these two events can happen at the same time. Therefore, these two events are not mutually exclusive. Since this is not mutually exclusive, I could use rule number 2 formula. Rule number 2 formula says that the probability of A or B is the probability of event A plus the probability of event B and subtract the overlap region between these two A and B. Okay, so in another word, if you want, I could explain in words. A means here getting number 9, the probability of getting number 9, that is my event A probability, plus the probability of B is getting a diamond, okay, then subtract probability of number 9, and it should be a diamond. Okay, now if you look at carefully here, there are three different probabilities now we need to figure out. So we need to find one by one. Okay, first of all, you need to find the probability of getting 9. Okay, you are given 52 cards of pack. So you are asked to choose one card. So what is the chance of getting number 9? Remember, there are four suits, right? Each suit has 13 of them. So each has 9, right? Each has one 9, one of them. So remaining all different, right? Differ from 9. There are there are 12 of them, right? This is for just one suit. This is just for one suit. For one suit, there are 13 cards. Okay, so one is number 9. Remaining 12 is separate cards. But you have such a four suits, right? Clubs, spades, diamond, and king, diamond and hearts. Therefore, getting number 9 is four possibilities. There are four nines in card pack out of 52. Then find this one. Now you have to assume that you are choosing a card. That card should be diamond. So remember, diamond is one kind of suit. So there are 13 of them. So there are 13 cards in diamond. Therefore, there are 13 possibilities out of 52. Okay. Now here is the key. You are choosing one card. That card should be number 9. At the same time, coming from the diamond suit, so you will find only such a one card. Therefore, it's going to be just 1 over 52. So put the fractions correctly. Okay. Now this is simple. All three fractions have same denominator. Simply you just add all the numerators. So 4 plus 13 is 17 minus 1 is 16 over 52. So if you simplify, you could divide by 4 here and there. So you should get 4 over 13. So let me leave the answer as a fraction. Okay, so that's the answer for this. Okay, so next one. In a hospital unit, there are 8 nurses or 5 physicians, and 7 nurses and 3 physicians are female. If a staff person is selected, find the probability that the subject is a nurse and male. So if you have such a problem, always easy to, if you have a table, we could call as a contingency table. So I'm making a table, okay? So this is nurse, and this is physicians. Here I am making number of males and females. So I'm simply making a table according to the problem. Okay. So if you look at carefully, there are 8 nurses and 5 physicians in total. 7 nurses and 3 physicians are female. So there are 7 female nurses and 3 physicians. So out of 8 nurses, 7 are female, means the remaining one should be a male nurse. And out of 5 physicians, 3 are female, therefore the remaining 2 is going to be male physicians. And if you could make like this table, it is always easy, right? Now, if you want, you could find the total for each case. So the number of total nurses, if you add all, possibilities of nurses, 1 plus 7, which is 8. So this is my total. And if you add all the possible physicians, it is 5. When you add 8 and 5 should be 13 in total. So there are 13 in total in that hospital, right? So make like this one table. So this kind of table is called the contingency table. Contingency table. So in the contingency table, you will have multiple cells, and each cell has separate numbers, and you could make like this. Okay, now let me read the question one more time. If a staff person is selected, maybe nurse, maybe physician, we don't know, find the probability of the selected person is either nurse or male. So now you could think of this as event A and this as event B. So basically you are asked to find the probability of A or B. Remember now I have two formulas. We have to find out which one is going to be here. So ask yourself what kind of events these two are. Are they mutually exclusive? Can these two events happen simultaneously? You are choosing one person. Is that possible to have that person is nurse at the same time as a male? Yes, it is possible. Therefore, this is not mutually exclusive. So this is not mutually exclusive event. Therefore, I am using the second addition formula. PAOB is P of A plus P of B, then subtract P of overlap A and B. Let us find one by one. P of A, choosing a person, the guy should be a nurse, right? If you look at the nurse row, there are 8 of them in total. So you could choose any one of these 8 out of 13 because you are choosing one person from the hospital. So you had to put the total. So this 13 is nothing but N of S, right? Now the second probability, the probability of choosing a male. So if you look at the male column, in total we have 3 of them out of again 13. Okay. So remember the denominator is always 13 because you are choosing a person in a hospital. So you have to put all the possibilities there. Now the next one is what? You are choosing one person. That person should be a male nurse, right? How many nurses are male? So if you look at that on the one person, it's a male nurse, therefore it is 1 out of 13. So simplify this fraction. 8 plus 3 is 11. 11 minus 1 is 10. So it is 10 over 13. Remember, your final probability answer is always going to be less than or equals to 1. You cannot exceed 1. Remember, we had the properties for the probability in previous section. We learned the probability of any event maximum occur, maybe 1. You cannot exceed. So your answer is always going to be bounded by 1. Okay. So my answer is 13 or 10 over 13. Yes, that's fine. Less than 1 answer. Again, like earlier, here also for not mutually exclusive event case also, you could extend the problem for 3 events. The probability of A or B or C is given by P of A plus P of B plus PC, adding all 3. But you are subtracting, you know, all the overlap plus adding, the common overlap. So this is the formula we have. Okay, so this is kind of complicated formula, but that is there. Okay.